Welcome to our new video for the Pure Mathematics course. Here we will begin to a very important topic, which is the integration or the infinite integrals. Now we already covered the differentiations and its different types and how to solve and to practice the exercises. But we have another very important topic, which is anti-differentiable. This means that the opposite type of the differentiation is the integration, which is, we can say, it is antiderivative. The antiderivative of a function f is a function of capital F such that the differentiation is equal to f of x dx. And the integration states that here the integral sign, here this is the integral sign of fx dx equal to the same value with constants. So if we have a differentiation for any function, we can get them the original function by make it integration and get the integration and get the main function and adding a constant. Here is some properties and basic integration properties. The first is if we have k constant, integration k constant dx is equal to k dk multiplied by x plus a constant. Also, if we have an integration for a variable over n, such as x to the power n dx equal to x over to the power n plus 1 over or divided by the power which is n plus 1, and adding our constant because we already in the differentiation get any constant derivative equal to 0. Here we add the constant to be care about the constant values. Now the same if we have integration for x to the power n, which is equal 1 over x equal to ln x, and ex integration for ex, it is the same, but we add the constant. If we have multiplying any constant by the integration, we can get the constant outside the integration sign and get the integration for our function like this. And also when we adding two functions f of x and g of x, we can get it by descriptive property for integration, which is this integration f of x dx plus or minus adding or subtracting the integral. Let's move to some exercises to be more practice in this topic, which is a very important topic. How to find the indefinite integrals. Here it's only a constant, so applying the previous rule, we got the integration for 5dx equal to 5x plus c. Note that our variable is x, so we get 5x plus c. Another example, 7 integration for 7x dx. Now we got 7 is a constant. We can get it by using the previous rule by 7 integration x dx, which is meant by 7 and multiplied by, when we adding a 1 over to this power, which is already 1, 1 plus 1 equal 2, and dividing with power, which is 2, here adding c, which is a constant. So our answer will be 7 over 7 times x squared over 2 plus c. Another example, find the integration for 1 over root t dt, not dx, dt. Here to find this, we can turn it into a power and getting rid of the radical sign and get the power for the denominator what a negative sign. So the integration will be here t to the power negative half dt, t to the power negative half dt. Till now we haven't do anything, we just modify our function to be in the from a vertical sign to be in the form of the power function. Now we will get the integration by getting the adding 1 to the power. So negative half plus 1 equal to half, and dividing over the power, which is half, plus c. Now turn it again in the form of the radicals. So we will get 2, which is the denominator of the denominator equal to root t plus c. Another example, find the integration for 1 over 6 x to the power 3. Again, we first here simplify the function before beginning the integration. So integration will be 1 over 6 here in the outside the integration sign, and getting the power in the denominator with a negative sign in the denominator here, x to the power negative 3 dx, and applying the new rules for the integration like this, when 1 over 6 outside, and when adding 1 to the power x to the power negative 3 plus 1 over negative 3 plus 1, which is equal to negative 2 x to the power negative 2 over 2, and multiplying 2 by 6 equal to 12, and getting x negative 2 in the denominator with a positive sign to be x to the power 2, and getting t plus c, which is the constant of our topic. Here we get an indefinite integrals of a sum and differences at the same time. Note that we have already 3 or 4 examples in the slides before. In this example, we just combine these examples together in one practice or one example by using the sum and the differences signs. So we have here 2, it's a constant, it's outside the radical sign. So 2 remain as it, and converting the radical sign to here x fifth root for x to the power 4 is equal to x to the power 4 over 5. So when we adding 1 to 4 over 5 equal to 9 over 5, and dividing with the same power, so dividing by 9 over 5. Minus or a negative sign remain unchanged, and also the constant remain unchanged, and adding 1 to the power of x to be x to the power 4 and dividing by the power equal to 4. Then the plus sign remain the same and the constant remain the same, and here integration for e to the power x is equal the same, it's e to the power x, not changing anything. And finally, negative 1 is equal to x because we already getting adding x at the first example, like here that was 5 dx was equal to 5xd plus c. Here the same with the same concept, negative x. So we just calculate all these numbers together carefully and compute it by using the signs not here. So we got this result that is equal to 10 over 9, 9 here, or maybe it's 9 over 10 over 9 roots here, the fifth root of x to the power 9 may be written in this form, minus 4 over 7 x to the power 4 plus 10 ex minus c plus minus x plus constant, our constant c. Okay, let's move to another ideas in the integration, which is using algebraic manipulation to find the indefinite integers. If we have an algebraic manipulation, we can simplifying it by using our distributive property. Let's take this example. We have integration for 2x minus 1 multiplied by x plus 3 over 6. So we will get 1 over 6 as a constant outside the integral sign. And here we can multiply these two by each other by using distributive property as we used before. 2 times x equal to x to the power 2. 2x times 3 equal to plus 6x minus 1 times x equal to minus 6x, and finally minus 1 times 3 equal to minus negative 3. Here 6x minus x equal to 5x, so we can substitute this value by positive 5x and then make the integration. Simply when 1 over 6 is out the integral sign, and here 2 is the constant remain unchanged, and adding 1 to the power and divided by the new power x to the power 3 over 3 plus 5, adding 1 to the power 1 plus 1 equal to, and dividing by the new power minus 3x plus c. So our value will be x to the power 3 over 9 plus 5x squared over 12 minus x over 2 plus c. This is set for this type of the integral manipulations. Let's take another example. If we have here integration for x to the power 3 minus 1 over x to the power 2. First, you can simplify this integral by this form: x to the power 3 over x to the power 2 minus 1 over x to the power 2, which is equal to the integration for here x to the power 2 from 3 equal to x, and 1 over x to the power x squared equal to x to the power negative 2. And then applying the integration rules simply. So integration for x will be x squared over 2 and negative sign negative times here x squared x to the power negative 2 plus 1, which is equal to negative 1 over and we can here convert it with a positive value, so it will be 1 over x, and the negative sign for the denominator will be positive here, and adding constant. Another topic in the integration calculus, which is the fundamental theorem of the integration calculus. Fundamental theorem of the integration calculus: if f is a continuous on an interval a and p, and f is very antiderivative of f on a and p, then we have this value for the integration. That's the integration from a up to p for f of x dx will equal p to the function of p minus function of a. Properties for the definite interval is a is greater than p. Then if a is function of f of x from a to p will equal to minus a and p, here will be changes f x of dx. So we can use this in our calculations like this. If you have this integration, find the probability for it. Here the integration is, our example is integration for 6 times x squared x minus x squared dx. Find the probability of x in between 0 and 1 over 4. So we will make our integration, but with definite integration by using upper limit 1 over 4 and lower limit is 0. So easily we will take our rules and make our basic rules for the integration, and then substituting with the values 1 over 4 and 0. So 6 is outside the brackets, and when we make the integration rule here, will be x squared over 2 minus x to the power 3 over 3. Then we will substituting the integration from f of p minus f of a. I mean, we will substitute with 1 f of 1 over 4 minus f of 0. So we will here substitute every x by 1 over 4 and get our value minus 1, substitute here with 0 and get our value, and subtracting here will be our value is equal to 5 over 32 minus 0, which is equal to 5 over 32. This is our solution for this type of examples. You can now get any definite function with two limits, upper limit and lower limit. For example, if you have here, let's take a simple one to be more easily used here. If you have a function, for example, here from 2 up to 3, and the function is x to the power 2 plus here 2x dx. So the integration sign will be x to the power 3 over 3 plus 2 times x to the power 2 over 2 d plus c. Okay, not plus c here. It's a different from 2 to 3. Now we will substitute by using 3, then 2. Here 2 was 2, so here will be 3 to the power 3 over 3, okay, plus 3 squared, which is 9, all this minus 2 to the power 3 over 3 plus 2 to the power 2. Here it's our value. Here we substitute by the upper limit here, then the lower limit here, and take the difference in between to be our result. Now you will clarify it enough if you practice more in the integration concepts. Thank you for listening.